A new class of Mars quakes reveals daily meteorite strikes. So you can imagine. Of course, Mars has no atmosphere. Daily meteorite strikes. So what does that mean for a manned colony on Mars? I guess that's not feasible. This is on phys.org by ETH Zurich. An international team of researchers, co-led by ETH Zurich and Imperial College London, has derived the first estimate of global meteorite impacts on Mars using seismic data. Their findings indicate that between 280 and 360 meteorite strikes the planet each year. That's what, almost every day in our day, forming impact craters greater than 26 feet across. That's huge. Geraldine Zan Husern, who co-authored the study, commented, "This rate was about 5 times higher than the number estimated for orbital imagery alone. Aligned with orbital imagery, our findings demonstrate that seismology is an excellent tool for measuring impact rates. Seismic chirp signals new class of quakes." Using data from the seismometer deployed during the NASA InSight mission to Mars, researchers found that 6 seismic events recorded in the nearby proximity of the station had been previously identified as meteoric impacts, a process enabled by the recording of the specific acoustic atmospheric signal generated when meteorites enter the Martian atmosphere. And now Zen Hausern from ETH Zurich co-lead Natalia Wojcicka from Imperial College London and the research team have found that these 6 seismic events belong to a much larger group of Mars quakes, so-called very high frequency VF events. The source process of these quakes occurs much faster than for the tectonic Mars quake of similar size, where a normal magnitude 3 quake on Mars takes several seconds. An impact-generated event of the same size takes only 0.2 seconds or less, due to the hypervelocity of the collision, of course. By analyzing Mars quake spectra, the team identified 80 more Mars quakes that are now thought to be caused by meteoroid strikes. The research quest began December 2021, a year before accumulated dust on the solar panels put an end to the InSight mission. When a large distant quake recorded, the seismometer reverberated a broadband seismic signal throughout the planet. Remote sensing associated the quake with a 150-meter wide crater. To confirm, the InSight team partnered with Mars Reconnaissance Orbiter MRO, Context Camera CTX, to search for other fresh craters that would match the timing and location of the seismic events detected by InSight. The team's detective work paid off, and they were lucky to find a second fresh crater over 100 meters, that's 320 feet in diameter. That's huge, obviously. Smaller craters, however, formed when basket-sized meteorites strike the planet, and which should be far more common, remained elusive. Now the number of meteorite strikes is newly estimated by the occurrence of these special high-frequency quakes. First meteorite impact rate from seismic data: approximately 17,000 meteorite falls each year to Earth each year. 17,000. But unless they streak across the night sky, they are rarely noticed. We're talking about shooting stars where we make our wishes. Now, most meteorites disintegrate as they enter Earth's atmosphere, but on Mars, the atmosphere is 100 times thinner than Earth, leaving its surface exposed to larger and more frequent meteorite strikes. Until now, planetary scientists have relied on orbital images and models inferred from well-preserved meteorite impacts on the Moon, but extrapolating these estimates to Mars proved challenging. Scientists had to account for the stronger gravitational pull of Mars and its proximity, of course, to the asteroid belt, which both mean that more meteorites hit the red planet. On the other hand, regular sandstorms result in craters that are much less well preserved than those on the Moon, and therefore not easily detected with orbital imagery. When a meteorite strikes the planet, the seismic waves of the impact travel through the crust and mantle and can be picked up by seismometers. Wojcicka explains, We estimated crater diameters from the magnitude of all the VF Mars quakes and their distances, then used it to calculate how many craters formed through around the InSight lander over the course of a year. We then extrapolated this data to estimate the number of impacts that happen annually on the whole surface of Mars. Zenhausen adds, while new craters can be seen on flat and dusty terrain where they really stand out, this type of terrain covers less than half of the surface of Mars. The sensitive InSight seismometer, however, could hear every single impact within the lander's range. Insight into the age of Mars and future missions. Much like the lines and wrinkles on our face, the size and density of craters from meteorite strikes reveals clues about the age of different regions of the planetary body. The fewer craters, the younger the region of the planet. Venus, for example, has almost no visible craters because its surface is continually reworked by volcanism, while Mercury and the Moon, with their ancient surfaces, are heavily cratered. Mars falls in between these examples, with some old and some young regions that can be distinguished by the number of craters. New data shows that an 8-meter, that's 26-foot crater happens somewhere on the surface of Mars nearly every day, and a 30-meter, that's 98-foot crater occurs about once a month. Since hypervelocity impacts cause blast zones that are easily 100 times larger in diameter than the crater, knowing the exact number of impacts is important for the safety of robotics, but also future missions to the Red Planet. This is the first paper of its kind to determine how often meteorites impact the surface of Mars from seismological data, which was a level 1 mission goal of the Mars InSight mission, says Domenico Giardini, professor of seismology and geodynamics at ETH Zurich and co-principal investigator for the NASA Mars InSight mission. He said such data factors into the planning for future missions on Mars. According to Zenhausen and Wojcicka, the next steps in advancing this research involve the use of machine learning technologies to aid researchers in identifying further craters in satellite images and identifying seismic events in the data. And this was from Nature Astronomy. This is provided by ETH Zurich on phys.org. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.